Good.
Okay, well, welcome back, everyone. We started with the pre-geologic period. Last week we did Rodinia, and this week we're going to look at Panatoa. And I also want to, again, keep in perspective that on a liberal estimate of how long our species has been around, 300,000 years, but it's safe to say 200,000 years, but give or take a couple of decades here and there. It is just to put in perspective, the short time that we have been around. So today we'll pick that up. That is if this will, there we go. And so we had where the Earth is formed a crust, and it has a mantle and it has an inner core, and it's a solid thing. It's covered in water, and because as carbon dioxide is released, their rocks are absorbing it. Therefore, it can't create an atmosphere, and the water turns to ice, and the planet is covered in about 10,000 feet of ice. However, volcanic activity continues, and in that process, it releases more dioxide, and the rocks now are covered with ice, so they can't absorb it. It now creates an atmosphere. And so we begin trapping some of the heat from the sun, so it begins to warm the planet, and the ice begins to melt, and it starts to become the movement of the Earth and its rotation starts to slow down, and we are starting to get to a point where this planet will be conducive to life. And it's during this period, Panatoa turns into Gondwana. That's just the way the surface and the crust breaks up and moves around, and how it becomes aligned. But what is happening is the ice is melting, the Earth continues to warm, and we continue building atmosphere. But the Earth, though the sun's heat, is still too hot for life to emerge, for organisms such as ourselves to emerge. And so it's about 460 million years ago that the environment starts to become conducive to life. Let's take a look at that.
Like that identity, but the very notion that
Okay, well, 1720s. Cortana pops up every now and then on my machine and causes things to move around. We'll start again.
Correspondent Chad Cohen digs down deep into the roots of the tree and uncovers some groundbreaking research into how life first began.
Everything on Earth that has ever lived came from an ancient ancestor billions of years ago. Perhaps a simple, single-celled organism like this. But from where did it come? From where did the first life emerge?
Life emerged from chemistry. After that, it's just details, right?
So at the root of the tree of life, it appears, is chemistry. Simple elements like carbon, hydrogen, oxygen, and nitrogen. But how did they get cooked together into the complex molecules of life?
We're here on the planet, and we must be here as a result of organic chemistry.
John Sutherland from the University of Manchester, England, along with co-authors Matt Pauner and Beatrice Gerland.
Beatrice Gerland?
Gerland.
Okay.
He and his team took on the task of looking for the holy grail of life.
You know what you want to make, but you don't have a recipe.
We can all imagine what this is like. In the kitchen, we bring together different ingredients all the time to make all kinds of different things. It's the recipe, though, that makes it all work. Take, for example, the cream puff.
Oh yeah, pâte à choux?
Okay, pâte à choux as it's known in French. In this case, I know the ingredients: flour, eggs, milk, water, butter. What I don't know is the recipe. So I might just try mixing all these things together and baking them. I could try different orders, different combinations, different amounts. But what you get is not pâte à choux. Too brittle, too hard, well, I have no idea.
Attempts to find the recipe for early life were unsuccessful too, even though researchers knew the basic ingredients.
Yeah, exactly.
Nobel laureate Jack Szostak and his team at Massachusetts General Hospital say that early life needed two things:
You need the cell membrane,
a container, something to live in and keep other things out,
and you need some genetic material, something that can allow the inheritance of information.
Every modern creature uses DNA to do that. It's an organism's instruction manual, genetic code, spelled out in chemicals inside this twisty double helix. DNA has long been hailed as the fundamental molecule of life. We also have RNA as well, usually described as DNA's helper. But now it turns out, RNA has a starring role.
Years ago, RNA was kind of a bit player in the cell. Now our picture is completely inverted, and we think RNA is really the important thing.
RNA has a genetic code also written with chemicals: A, C, G, and U. They're used to help build the proteins that make up the cells in our bodies: skin, hair, brain cells, the heart. RNA helps make them all. So what's the recipe for RNA? It's made from 3 parts: a sugar, a phosphate, and a single letter of the genetic code, a base. Each of these parts is made up of simple chemicals that existed on the early Earth, but nobody has been able to put them together. That is, until John Sutherland came along.
We were the guys who stood back and looked at it in a different way.
It's one thing to make chemicals in the lab, but there were no labs on the early Earth. So Sutherland tried to replicate the conditions.
In some ways, simulate what that Earth would have been like.
Simulate the actual chemistry that took place.
Starting with their version of what Charles Darwin suggested as the perfect spot for the source of life: a warm little pond.
The pond itself is actually the little round-bottom flask.
And because it was a warm little pond,
It's around about the temperature of a cup of English tea.
Sounds nice.
and so they tackled the problem at hand, trying to make RNA. Knowing what chemicals it would take, the question was how to cook them together.
People have known the ingredients for some time now, but the recipe has not been really working out.
You actually have to be the person that writes the recipe book.
So that means we have to go back to the kitchen and try to combine our ingredients for pâte à choux in a new way. Remember the ingredients: eggs, milk, flour, water, and butter. We combined them before with no luck. But now we have a real chef to help us.
Well, you had the right ingredients,
Right.
but you forgot one very important step. It's that intermediate step.
Chef Richard Coppage of the Culinary Institute of America explains that I was missing an all-important intermediate step.
You didn't pre-cook the mixture.
I can't just mix these things together and bake it.
No,
And
because that's why you have this.
So pre-cooks. What does it mean to pre-cook something?
Some of the ingredients need to be cooked together first.
This is the intermediate step.
That you didn't do earlier.
Yeah.
I first cook the water, milk, butter, and flour together. No eggs. Then,
Take it to the mixer. Now you can add the eggs.
Okay, now, finally, okay.
And you get just the right mixture.
All right, that's ready to be baked.
The result,
Wow, they look perfect. Without that intermediate step of pre-cooking, you really don't have pâte à choux. It's not much of anything without that intermediate pre-cooking step.
Great.
and apparently, that was the problem scientists were having with RNA, trying to combine all the parts together. And that's not the way to do it.
No, it's not.
So Sutherland's team took their own intermediate step. First, they created a hybrid made of a sugar and only half of the base, the part that holds the genetic code. This intermediate substance came together in the flask through the simple process of evaporation.
It looks like a smear or a smudge on the inside of the flask.
On the early Earth, the intermediate would have formed through evaporation, made its way up into the atmosphere, and then fallen from the sky.
And so this would come down in rain, or if the temperature was cold, it would precipitate out as solid particles and fall to the ground, almost like a kind of organic snow.
And as in the lab, meeting up with the remaining chemicals in perhaps another warm little pond and attaching together in the final step. And it worked. For the first time, scientists created a building block of RNA, what's called a ribonucleotide, containing the base C. In hindsight, pretty simple.
It never occurred to me to try putting them together in a different order, so it was not obvious.
It was, in fact, an amazing accomplishment.
Because if you take the right mix of ingredients in the right order with the right set of conditions, you can cook a nice piece of pastry. I can make a ribonucleotide.
And it came together in simple steps that could have taken place on their own on the early Earth.
My team and I have recreated an early Earth scenario and let it run. And the chemistry just does it on its own.
But that wasn't all. They took their piece of RNA and subjected it to something else easy to come by on the early Earth.
Light.
Yes, sunlight.
And so if you hit the switch, you'll see what happens when the sun shines.
Something amazing happens. The light shining upon their sample turns some of the C bases, the bit that makes up the genetic code, into U's.
So 2 for the price of 1, just by having the sunshine.
They had discovered a natural pathway to 2 of the 4 letters of RNA, letters that code for the proteins that build all living things.
We were pretty happy, actually.
Understatement, or?
No, they were happy. I would never say the contrary, but in an English way.
We might have had a trip to a local pub.
And so, while we're a long way from figuring out exactly how life got started,
They've really, I think, solved one of the central hard questions in prebiotic chemistry.
They filled in a piece of that mysterious underside to the tree of life. Because as we trace our origins by looking down, chemists like Sutherland are seeing things in a different way.
What you see looking down from biology is what we see looking up from chemistry, and we can actually establish a link between the two.
A pathway from simple to more complex chemicals until chemistry becomes biology. They've given us a glimpse of where we come from.
Okay, well, and this is, to me, this is one of the more fascinating clips. Understand, many of us have learned about the creation of life being a mystical, religious kind of experience. And as many theological scholars will say, is that you should look at the literature, as a metaphor, as, not being a historical document in the sense that it's giving you factually, here's how these things came about, but on a broad concept. So if we take that broad concept, you can look at the basic chemical elements of life come together here on Earth, introduced by meteorites delivering it into the cloud and along with water and before it solidifies and that the ingredients are there, and it takes time for the elements to actually come together and to form a basis of forming life. That can be the creator, right? Putting it all together and being the force, the higher power behind the creation of it all. But what I find fascinating about it is that this explains kind of where we come from. This is the very roots of it. And life begins really during the pre-geologic period in the form of bacteria. And then we have a cell that emerges, Pichia, which has a spine. And then we get to what becomes an organism that can live above water. And that is Tiktaalik rosea. Let's have a look at that.
Tiktalik's heavy-duty fin still helped it to swim. But if it hit the shallows, the bones and joints would help to push itself up and punt around. But this new limb didn't just help mobility in the water.
Sorry, something happened here. Sorry, I had a little glitch here.
It became the driving force behind one of the most spectacular events in evolutionary history. The arrival of the first vertebrate animals on land.
So now we get our first emergence of life above water. Let me get to this next one here. Okay. And this will come up right. There we go. And so, mind you, while, this is now as the Earth is starting to cool and the environment is becoming more conducive to life above water, we have oxygen and the sun's radiation. They create an ozone. And the ozone, which is a component of the atmosphere, remember the carbon dioxide creates the atmosphere, we add ozone to it, and that allows for really an abundance of oxygen and for temperatures starting to come down to 90 degrees. And it starts with that abundance of oxygen allows for things to grow large, and we then get dinosaurs and other animals that are huge sizes. But and we'll talk about what happens with the dinosaurs, but it's during this period that the Earth is becoming conducive to life.
Before Snowball Earth, primitive bacteria emerged in the oceans. But surely they couldn't have survived an ice age 75 times longer than the entire span of human history. If something has survived, then life may be found where it was last seen, in the oceans. Now, 540 million years ago, in an ocean full of oxygen, those primitive bacteria have evolved. A handful must have clung on through the big freeze. There are plants scattered on the seafloor. And something else. What looks like an armored slug takes up residence. It's called Wiwaxia, a new generation of complex multi-celled organisms. The Earth enters one of the most dynamic periods in its history, the Cambrian explosion. Increased oxygen levels allow creatures to grow larger and develop bony skeletons. There are worms, sponges, and these trilobites, distant relatives of insects, lobsters, even scorpions. Life in the oceans blossoms. From microscopic bacteria to monsters. This is Anomalocaris, nearly 2 feet long. It has large eyes, razor-sharp teeth, and grasping limbs. All it has to do is take its pick. The trilobite can't right itself. Its soft belly is exposed. Also found in the sea is Picaia, only 1.5 inches long. They may be the first organism with a spine. Over millions of years, this simple structure will evolve into the spine that keeps us standing. Expecting to find life in ruins, the oceans are in fact full of life. Where trilobites scavenge, monsters prowl, and where creatures begin to take on familiar forms. Beneath the waves, there are already tens of thousands of plant and animal species. The advance of life seems unstoppable. $460 million years ago, the plates had been moving again. A new continent now exists, Gondwana. It's 90 degrees and oxygen levels are close to what they are today. The land should be covered with plants and crawling with creatures. But there's not much here. besides a few patches of algae, there's only one explanation. The sun. It blasts the surface with deadly radiation. So the complex life in the ocean doesn't stand a chance on land. But 30 miles up, where the rays enter the Earth's atmosphere, something is happening. When oxygen meets the sun's radiation, it turns into another kind of gas called ozone. This gas forms a blanket around the planet and absorbs the lethal radiation. Over 120 million years, the ozone layer gets thicker and prevents more and more radiation from reaching the Earth's surface. Without this layer, life on land simply wouldn't exist. Now, shielded from radiation, life takes off. Small, mossy lumps are the first land plants. They pump out even more oxygen. Levels soar. $375 million years ago, a new species lives in the water, swimming. It's a strange fish called tiktaalik. It uses its neck to raise itself up. And its fins function as legs, allowing it to move out of the water. This is one of the most important moments in the making of our planet. Over 15 million years, creatures like these evolve. They grow stronger limbs and spend more time out of the water, where plant life is exploding. Until 360 million years ago, their relatives, called tetrapods, make the land their home. From tetrapods, four-legged vertebrates evolve into dinosaurs, birds, mammals, and eventually, humans.
And so now we have this life of plants and animals, mammals start to roam the earth above ground, and it changes what becomes this space and makes it conducive for us. Let me get to...
Planet Earth is unique. An immense ball of rock, 25,000 miles around. Modern animals had arrived on Earth. The high level of oxygen that had triggered this explosion of life in the seas was also making a final modification to the atmosphere. Over the next 100 million years, oxygen reached today's high levels. A level dense enough to allow an ozone layer to form in the upper atmosphere. This layer was to free life forms from the oceans. Previously, powerful ultraviolet light would destroy any organism not protected by the water. Now, the ozone layer would act as a UV shield. "400 million years ago, the Earth is more than 4 billion years old. Over the next 100 million years, the continents would once again converge. And this time, thanks to the ozone shield, life was free to leave the oceans and conquer the land. Planet Earth had become a world of tropical swamps." South Georgia, USA, the Okefenokee Swamp.
The Okefenokee is believed to be what we would call an analog, a modern analog, or an environment that's very similar to the wetlands that existed on Earth in the past.
Fred Rich is an expert on prehistoric swampland. Geologists like him believe that this freshwater swamp closely mimics the surface of the continents 300 million years ago, in a period known as the Carboniferous.
The Carboniferous was an unusual time because it was the first period in Earth history when large plants occupied Earth's surface, 40, 50, 70 feet high, that grew in dense groves and produced a vast forest canopy in a steamy tropical jungle atmosphere that was something entirely new on the face of the Earth.
This dense tropical swampland would dominate the Earth for the next 60 million years. The evidence is present on all of today's continents in the form of coal. The coal we use for fuel was formed from millions of years' worth of accumulated plant matter, most of which existed less than 300 million years ago. And it formed because of the unique way freshwater swamps decompose.
Okefenokee is derived from a Native American word that means land of the trembling earth. It's not very easy to walk through the swamp because the subsurface is soggy plant remains.
The fresh water prevents the vegetation from decaying, allowing huge amounts to build up over time.
Beneath me is not the regular sort of soil that you would have in your backyard. The soil that you see here is the plant material that accumulated last year or perhaps 5 years ago. It's leaves, stems, twigs. There's still a good bit of water in this, but if we put this under a tremendous amount of pressure and add some heat by covering over with layers of rock and leaving it in the ground for millions of years, eventually it will change to this. This is a piece of bituminous coal, and it's on the order of 200 million years old.
As the dead plants were transformed to coal on land, the shallow waters surrounding the continents were preserving millions of generations of dead marine organisms that would become our other major fossil fuels: oil and gas. Every year, mankind mines almost 5,000 megatons of coal, 30 billion barrels of oil, and 3,000 billion cubic meters of gas. This fertile period of Earth history has given us much of the energy we use today. Without it, the Industrial Revolution may never have happened. Plants were not alone in making a new life on the land 300 million years ago. As time went on, first enormous insects, Then ambitious amphibians. And finally, early reptilians left the seas to take their first steps on the muddy shorelines. The U.S. East Coast back then would have teemed with monsters. 3-foot millipedes on land, 2-foot dragonflies in the air, and proto-alligators patrolling the nearby waters. The world was over 4.25 billion years old, and for the first time, the surface was host to a complete modern biosphere.
Okay, so what I want to highlight is that, you know, it's a really relatively short period of time that we have. I know this is outside of the current slide. Let me do that. Come on. Stop that. Back to here. There. And so it's, you know, where the Earth is here for 4.6 billion years, and it's really over 300 million years that the biosphere takes shape, and life emerges. And beginning with bacteria that was first introduced 3.5 billion years ago, then 530 million years ago comes a cell with a spine. We then get an organism that can come above water, and the atmosphere is becoming conducive to life above water. And, you know, at first, there aren't any plants, there's no growth of anything. Then we get an ozone that protects us from the radiation of the sun. And we have plant life starts to grow, insects start to grow, all of that kind of thing starts to emerge on Earth 300 million years ago. And all those plants eventually get, you know, under a swamp-like condition, and they become fossil fuels. And again, these are created 300 million years ago, and we come along in the past 200,000 to 300,000 years. We come to discover these. This has now been made into coal, and coal becomes the linchpin for the Industrial Revolution. And that Industrial Revolution, we're now looking at the consequences of it, which is creating a global warming, making it less habitable for humans to exist above water. Anyway, it's just looking at all of those ingredients and how we get to here that I find fascinating. And it makes for a recognition of our existence within the overall tale of how this Earth, this cloud of dust and rock, came together, became a solid surface, and became an environment that would be conducive to life. And we see that this oxygen-infused biosphere is creating huge insects and that kind of thing. It will also give us the dinosaur, which will emerge in our next series of classes, which, as this atmosphere is changing, the continent continues to drift. There's a debate about, you know, is it continental drift, or is it, you know, tectonic plate shifting. The terms, can mean different things to different people, but it's essentially that it is a moving object, and it comes together in this thing that we have the name of Panatoa, moves again, becomes Gondwana. It will move again and become what we refer to as Pangea, which has all of what we know of the land surface connected together in one spot. And when it does that, the dinosaurs will also emerge. Okay. With that, we'll next week look at Pangea 300,000 years ago. And again, putting it into perspective that we come around about 200 to 300,000 years ago. Okay, we can open up for discussions, and wait a second, I wanted to stop the share. Let's stop it. There we go. Okay, George, Lauren, we can open up for comments, discussion.
Okay, let's use the raise the hand function, please.
Hey, Sal, before we get going on this, so I know that they found fossils and things, but some of the other stuff from the very beginnings, really last week's lesson about how this all formed, how do they know all that stuff?
They guess, they're guessing, they make it up. They know, nobody else knows. So hell, they just create this story. It's fun. You make it up. No, seriously, they're, somebody else during one of the classes mentioned how they are being able to measure radiation and lead, of course, with carbon dating and that kind of thing, to be able to, discern when things existed and how they emerged. It's, it's the science research. You come up with a theory, then you try to find it, can you prove it or disprove it, and you do an investigation to learn about this stuff, and it's really pretty remarkable. It followed, the scientific investigation is the same, not the same, close to exactly the same process as a security investigator would go about investigating a crime. So you start with a theory, you then inject information that you don't have to try to make a story, a narrative, and then you start testing it. And the information that you injected, you then test it to see, is it real? Is it not? How can we come up with things to test it? And it's really quite remarkable. And mind you, again, this information is stuff that was developed over the past 200 years. So it's really very new science.
Nancy, why don't you go ahead?
Okay, I noticed that kind of heavy set, slick alligator looking animal that came out of the sea and was supposed to be one of the first ones that had feet that were able to walk on land. And the narrator said that was one of the first ones that came out, and that, all of a sudden we've got life on Earth. But over on the right-hand side, there was a big fluffy bird. So I'm wondering if the birds came in a different category, if maybe they got here a different way, and that's why why else would that big fat bird be over there when the alligator was supposed to be the first thing coming up on land?
I don't know. I think the birds followed after Tiktaalik rosea came above water.
So you're thinking that the birds came after the vertebrae.
Right.
The fish first, and then the amoebas, and then the vertebrae, and then the birds last.
Right.
Okay.
Right. That's how I understand it.
Well, I just want clarification.
Dave, maybe you can help clarify it for us.
I'm not sure I can. It's like you say, it's a bit of a guess based on clues and stuff. I thought birds followed dinosaurs actually, so there's a lot of evolution before birds came along.
Yeah.
But my comment is this, that I noticed at that one point in the film where one critter grabbed the other critter, flipped it over and ate it.
Mm-hmm.
And I thought, isn't that interesting, that why do we need to consume other life forms? Whether it's plants or animals, we consume other life forms. Why do we need to do that? And I was thinking, okay, well, let's go right back to the beginning when you got basic bacteria or one-celled animals. And why did one-cell animal feel like it needed to somehow absorb its neighbor? You know, maybe it was better off by having both pieces together, absorbed together or something. And so the things could evolve and get better by adding on other critters or something. But, you know, it's interesting. Why do we need to eat other life forms?
Because of Darwinism.
No, I mean, I think it's a great question. I don't know the answer, but part of what I find interesting is that as we do that, we start mixing up all of our cells and our genes, and we become more diversified. It leads to that phenomenon of evolution, and that the more we continue to be a changing species, a changing life form, the more resilient we are. You know, when I think of Neanderthal, who really was far more powerful and dominant than Homo sapien, Neanderthal was very conservative and didn't want to stretch out that far. Had their environment, had what, you know, would feed them. They wanted to stay within that realm. Homo sapien kept wanting to wander off and to do different things, wanted to be more diversified. And so we survive, and Neanderthal didn't. So maybe there's something like that that's connected to it. But yeah, it's curious as to how those behaviors emerge. Because I would have to think that when we're at the single cell is, you know, living in water and has whatever nutrients it needs to survive there. But what happens when it grows bigger, and what other nutrients is it going to need? What other chemistry will it need to survive? It's fascinating. Yeah, I don't know the answer. Yeah.
We'd like to welcome Carol from her new abode.
Yes, I'm here. And one of the most interesting things about this is when it said that chemistry and biology came together, because that is almost like we've solved these problems, because chemistry and biology used to be totally separate forms, separate ideas, separate everything. And now it's all come together and makes a lot more sense, so that when scientists study this, they have to look at it from not only a chemical relationship, but also the biological relationship.
Sure, that you need a something that is going to house the chemicals so they can come together, and that it needs, you know, the instructions to tell it what to do. It really, I just find that whole segment just utterly fascinating. It is, yeah, I can have all the ingredients here, but that doesn't mean that I'm going to be able to create life. It is, what's the recipe? And if you don't put it together in the right order or mix things in the right way, then it wouldn't have happened. So the fact that it all comes together, and it's not done by, you know, a scientist at MIT. What I mean, there weren't any scientists at MIT, right? This process takes place, and ultimately we get scientists at MIT who can look back and try to discern how did that occur. It just is remarkable, and I think it again, for me, it is to put my existence within a perspective of how the whole planet comes together and how these events come together that result in my existence. And it raises questions again of what is the purpose of our existence? What's meaningful? What should we care about or not care about?
I'm going to jump back in here again because I've got a question in the chat from Lucretia. She wants to know, what is the meaning of the names of the periods like Gondwana, Panacea, etc.?
Oh, Panatoa is I'm sorry, I forgot. I had it written down. I believe it's a Greek word, and I don't remember what it's for. I know that when we talk about the Cambrian period and the other different periods over time, that what they're related to are the mountains where the fossils were first discovered that helped answer those questions. So those pre-Cambrian and all of that is really related to the locations where they found fossils that led to the discovery that they're talking about. But anyway, so I forget what the name's related to, but I'll have it next week.
Okay, Margita.
Yes, thank you. So what I saw is the beginning of pattern of life, which is survival of the fittest, the big devouring the smaller. The more teeth you have, the more viable you are. And to the question of why do organisms eat others, it's to replenish your energy. If your energy level is down and you're about to go down and expire, you take up the energy of another life form, whether it's a plant or an animal or what have you. So interestingly enough, we see that this hasn't stopped, right? And Sal, you always said, well, why can't we learn to be kind to each other and love and etc. And yes, and we all, would like this to be the case. But as we can see, we're creatures of this planet, and it is in our DNA, in our structure from the beginning, that we have this drive, the reptilian part of our brains, so to speak, is to fall into this, the survival of the fittest. The strongest will eat the weaker one. To me, the big miracle, or what astounds me, it makes me wonder, is not that humans are cruel to each other, because nature is cruel. It's all there, nature is cruel. There is no kindness in nature. But for us as humans to have developed a brain that can conceive of a notion of not devouring the weak, but building a whole structure of ethics to protect the weak and have some kind of moral code that goes entirely against our reptilian DNA, that's the miracle, not the other way around. The greed, the brutality, that's part of our, the mindless creatures we were, and that are still in our brain. But the miracle is that we can love and be kind and jump over that old archaic brain. And to me, there's the hope. And so I'm forever an optimist. I just marvel at human beings being able to do that. And, you know, everybody struggles in one way or another to not be selfish every day.
Well, I would just to moderate it a bit is that I'm not sure it is our nature to be survival of the fittest.
Well, why do you say that, Sal? It's so obvious.
But mind you, for 200,000 years,
yeah,
it wasn't survival of the fittest, the individual. It was survival.
Well, that's what I'm saying, that at that point, our brains had developed to understand to survive, we have to cooperate and be a team and mitigate some of these brutal tendencies, but you were still brutal to other tribes.
But what I'm saying is, mind you, really from the beginning that we go hunting for food, when I say we, I mean our ape family going back millions of years. They had to do it as teams in a cooperative manner. And we continued that. We really don't get to the selfish part till about 10,000 years ago. Now, there may have been evidence of it before, but the real, milestone comes with when we start creating things like property and excess. But we were able to survive where Neanderthal didn't because we were cooperative as opposed to
I agree with you, Sal, but this is something we had jumped over the part of the reptilian brain and went to the frontal lobe and find that's the best way to survive is to cooperate and take care of each other, of the young and the weak and blah, etc. But that does not negate that it's there. It was there from the beginning. It is still there today. This is the eternal struggle in humans. And what you're saying is it came more to the forefront once we had agriculture and empires and all. But what I'm seeing is this has been with us, and it was a miracle for us to be able to develop cooperation and kindness and some kind of ethical and legal system for protection. But it is still, it's like a car, that was modernized, but the old parts are still in there. So we've got our old clunker in there.
I understand the point, but let me say this. Today in the military, right, we have to train people to be mean with other people. Our natural instinct is not to hurt each other. And the military had to study it because we had, in World War I, they realized that soldiers were not able to shoot another soldier if they saw them. They could shoot into a general area, but they couldn't shoot at a person. So the military conducted studies with psychologists to try to ascertain, why is this the case? The estimate was that 1 in 5 would be willing to shoot the enemy in World War I. And so they use B.F. Skinner's behavioral modification to start to get people acclimated to hurting other humans. So military training was really the subtext was purely psychological. By the end of World War II, the number had gone to 25% were willing to kill. By implementing these training techniques, the number went up to 50% in Korea. By Vietnam, it was up to 95%. So it was a deliberate process to get people in the military willing to kill other humans because our natural instinct is not to.
Well,
it's just interesting.
Yeah, I see it more nuanced. I think our natural instinct is also to be brutal, but we're controlling. And what you're describing may be that they had to go back and allow these old instincts to override what we have built for 200,000 years. But it's there. Just look at the news. Every day you see brutality. So it's very easy for some people to kill and torture others. Look at what's happening in Ukraine, these modern young Russian soldiers.
I understand, but that's the actions of the people of power are of a select few, and they don't represent the whole mass of humanity. I think what we look at when we look at the broad picture is that we are social animals. We are more likely to talk you to death than we are to want to just go and kill you. We will, that's it. We really want to engage. That's our natural instinct. That's from my studies. That's what I would say. Yeah.
Interesting discussion. Linda, what do you have?
You're probably going to get more into evolution and all, but I think back to Herschel Walker saying, well, if we evolved from apes, why are there still apes? And he doesn't understand that we have a common ancestor, right? We have a common, and I guess that one's gone, right? And we went off in two different directions. It's I don't know anthropology or whatever the field is, but isn't that the common ancestor is no longer there? But we did evolve from a common ancestor, but I guess the apes went one way and we went the other way.
Well, no, we are a part of the ape family.
Okay.
We are a branch on the tree.
Branch on the tree, yeah.
And the contemporary studies of the ape family show them to be very compassionate. We think of the alpha male, but the alpha male is often moderated by the females. There's a sense of community, right and wrong.
Mm-hmm.
It's really the Franz de Waal, who is a researcher at Yerkes, probably retired now, I don't know, but I really enjoy his books because that's what he writes about. And he writes about how we ought to really look at our ancestors and take lessons from them because it's, that doesn't mean that they don't have fights and stuff, they do, but they're a much more compassionate existence. And I think it does reflect a lot of what are human. Humans are more compassionate than not. We can get frightened and our fears can be used to make us do things that are not, natural to us. But that's a whole nother, and again, psychology gets used as to how to get into our brain and then spark it to do things that are not part of our nature. So
I have cats, and occasionally I take one out for a walk and they'll get a chipmunk or something. And if I would let him, he would play with it and he would hurt it, but he's not hurting it like we hurt, people, PETA goes after people that actually keep dogs in horrible conditions and actually are cruel to them. He's not being cruel, but it is his nature. But it looks,
I'm saying, yeah,
it looks cruel, but it's not cruel because he doesn't have that thinking.
Sure.
Mr. Berry.
Yeah, I'd like to just make a comment, a clarification. We're talking about evolution and Darwin did talk about survival of the fittest. But by that, he meant the ability to sustain life and to pass on DNA, to replicate. And what he said, and this is sort of a take on his quote, that it's not the strongest or the most intelligent, but it's those who are able to adapt to change. So as the Earth evolved, those species that survived and could reproduce were those that adapted to change. And so this concept of the strongest being the winner is not what Darwin said. So because the lion kills the antelope, that doesn't mean the lion is going to survive, some change in the Earth. So as the Earth evolved and went from warm to cold, from ocean to dry land, evolution and survival really were those creatures who could adapt to change.
Yeah, no, I completely agree. The Darwin's, concepts have been kind of cherry picked to be able to support other agendas and not really a faithful representation of what he was saying. I mean, and part of my vocalizing against the idea of the survival of the fittest is more based on how it's been, spun, not as to what he actually was talking about. But the spin is, hey, sure, I've got $50 million and that person is starving to death. It's not my problem. I live in a world where it's survival of the fittest. That's it's kind of a perversion of what the concept actually means. So yeah, thanks for pointing that out. Yeah.
Maxine, what do you have?
Well, I started about 3 people earlier, and now I don't know what I have. But one, you aware that Franz de Waal lives in Atlanta, and he's here. Yeah. The other is, are you aware of the study that showed only within the last 25 years, I think, that chimpanzees without cause will attack another village? And that was the first time that we realized that they weren't that there was an aggressive piece to their DNA.
Yeah, no, it's like with anything, when you think, you got a handle on this is how they are, there'll be some act that, throws a whole different interpretation into it.
Well, I wondered between what you and Margita were talking about is why can't it be both and? I mean, if obviously we've evolved, we have evolved with a piece of greed as part of our nature. Agriculture didn't have to go that way. So the richest could have said, here, I'm near the river, you in the back, let me just transport it to you. But it didn't work that way. So we are designed, it seems, with greed and power, as well as angelic nature to care and cooperate. I see them both within us.
Yeah, I think it's I guess my my paradigm, my understanding, my narrative, my bias, if you will, is that those of greed are the few, are the 1%.
I
don't know that that's correct.
1%.
Yeah, I don't know that that's correct, but I'm just saying that's my bias. That's my paradigm. And so what you have is a very small elite that drives a lot of discontent amongst the masses. So what we get is, on one hand, we have that very angry, recalcitrant person who is not going to cooperate with whatever the program is and is going to want to might makes right, ends justifies the means, all of that. On the other hand, we have the healthcare worker who is exposing themselves to deadly viruses to go and help other people. If I break them down into the numbers, are there more compassionate people, or are there more, greedy, belligerent people? Well, my sense is that, and based on a lot of stuff that I've read, is that we are more of the compassionate side, but we can be manipulated by fear into setting aside our compassionate side because we're frightened and we think we have to do these things to defend ourselves. So for what you do when you're going to agitate people to go from being kind and compassionate to being aggressive and all the rest of that, right, is you have to frighten them, and you have to then get them to believe what they're doing is not aggressive, it's defensive.
Well, I totally agree with you. And I think as a base core foundation, human beings are vulnerable, and they'll do anything not to feel vulnerable.
Sure, and that's it. Is that again? If I go after your vulnerability, your sense of vulnerability, and I frighten you, I get you to believe stuff that isn't true. It is. I can get you to do a lot of things that you would not otherwise do.
Somebody asked a question earlier. Why was it? That's ridiculous to ask it the way I'm doing it. But isn't it interesting that the way evolution created, we're a giant delicatessen in the universe. We eat each other. And what could have been different in some way so we didn't have to eat each other, or maybe just plants, but it was designed that way. I mean, it's the master plan.
Yeah, but mind you, we really don't eat each other. We eat other organisms.
Well, okay, I mean
that are kind of, we see them as not one of us, not human. And that's that us and them that gets used a lot. I mean, these are all, they all play into each other.
Yeah, but you name a cow and you pet it, and suddenly it's hard to kill it.
Right.
It's very confusing, that our nature.
Yeah. Go ahead, Margita.
Okay, I wanted to just a little PS here. When I was talking about that, I see, the old reptilian, selfish, greedy part of just reacting, devouring, angry, and then the other more recent part of our brain that allows us to create compassion and kindness and jump over that old system. Just watch little kids. You see both of those. So little children, you see a lot of selfishness, the way they want to play and not let others share their toys, etc. And if somebody grabs your block, then you can slap them or kick them and throw sand at them, etc. in all the details, different situations included. On the other hand, a little child will start to cry when another child is crying. So we're primed for that too. So what I'm saying is we have both. We always have both in us. And it is the role of parents in education, and then religions, philosophy, rules of law in society, to make sure those two sides are balanced, and that the brutal side of our organism is not allowed to take over. And with children, when you're a teacher, and just watch some a group of teenage boys that have had, or college boys that have had too much alcohol. I don't have to go into detail, right? So there is both there.
Okay. All right. Yeah, good points. Good. Go ahead, Ralph. Ralph, you need to unmute.
Okay. Am I unmuted? I think
yes.
I am.
Yeah.
It's been interesting how a lot of the discussion today has been about evolutionary psychology, really. And I just wanted to mention to people, Shai Robkin taught a massive, fabulous class on this a couple of semesters ago. It was wonderful. And it focuses on all of this, how we are different from Neanderthal, how we are different from the other human species that have been found now, why we succeeded and others didn't, how the tribes of us in the early millennia interacted, and really why we are the way we are. I got a lot out of it. He used as one of his teaching texts a book called The Moral, that I highly recommend, by a guy named Robert Wright, W-R-I-G-H-T, The Moral Animal. And I actually read it twice in a row. I was so impressed. That book is fantastic. And a lot of what you all have been saying is exactly what he gets into in the book. Certainly all those base impulses are in us and they are not going away. But it's also true that because of how we are, because of the evolution of which particular human, the ones that could find some degree of cooperation were the ones that succeeded. And the ones that would do nothing but warfare were the ones, ironically, who were essentially
That's why the Republicans won't win.
that applied between
It'll take a while.
and it apparently applied between groups of humans, which would mean that evolution would bring the traits forward that had some place for cooperation. So the attention kind of gets focused on the brutality and the competition and the killing. But what gets a lot less attention is the cooperation within species, and also even between species. If you look for it, they find more of that now when they do population counts and stuff. They come up with explanations that require some degree of a tolerance between species that wasn't expected. So anyway, highly recommend The Moral Animal. And boy, I wish that Shai Robkin would teach his course again.
Yeah. He, I think
not miss it if he does. It's awesome.
Yeah, no, I think what he does is really a great class. And it's kind of interesting in the American Historical Association. I get their newsletter, and you get historians, raising questions to each other and that kind of stuff. And one said, one of the things he's thinking about is that have we as historians focused more on wars and conflicts and not given attention to those who were negotiating diplomatically for peace, and those that were successful? Have we not really explored that? And so there's kind of a discussion going on about it.
Right.
It's really quite interesting. Yeah.
It is.
Thanks, Ralph. Hey, Denise.
Hey, Sal, how are you?
Good to see you.
Yeah, I wanted to go back to what Shai Robkin has said, because the one thing he does say is that the way our brains work has not evolved commensurate with the progress that we've made over the generation. So we're still thinking like in the way that we process information and ideas, we are still thinking like prehistoric man. There have not been enough generations living in altered circumstances for the way we interact to have evolved. And I think that's important as you think about socialization in this whole process. You can talk about, we have this innate nature, but then of course socialization impacts it. So if you look at a country that's been involved in a war for 20 or 30 years, the way people think and have been socialized is very different than one in, like Sweden or Denmark, where they're all happy and right. And those have tremendous influences on our instincts to interact with others and with each other.
Yeah, sure. No, you see, I would, again, I would, refer back to how we existed before agriculture, and what happens after agriculture, because it's really, to me, in the human experience, once that we get introduced to greed and wealth and power, that's when we really go to hell. We were much better before then. We took care of each other, and so I think it's important. What I think is interesting is in a class that's really looking at the history of the Earth, it's not so much about how the Earth formed and all of that. Yeah, that's a good part of it, but it ultimately raises the questions about where do we fit in this whole thing?
Right.
What is our purpose? When you look at the magnitude of millions of years and the continents moving around and all of that, it really the things that we get, kind of engrossed in, really pales in comparison. I mean, is it really that important to be the president? I mean, it's not. Is it really? It raises a question, like, if I'm that concerned about what's happened to my IRA in the past 10 minutes, is that really that important? And I think that's kind of the very philosophical kinds of question for which there's not an answer. I mean, each of us has an answer to that, but it's not like that's what should apply to everybody. But it's kind of fascinating how it really provokes that kinds of questions and kind of thinking.
Yeah, I also think once we got to greed, there's also that divide from the Industrial Revolution going in one direction, because you can see Eastern societies, for instance, that had a much different concept of community and individual within the community and group good, as opposed to where we went with the Industrial Revolution, which was every man for himself. Now that, and you can see how places like China are changing in response to that industrialization again. That whole new industrial revolution that's happening there is changing how people see their family, their responsibility, and their individual selves within society.
Yeah, I mean, right. They're now on the bandwagon.
Yeah.
And marching to hell with us.
Mm-hmm.
Go ahead, Maxine.
Maxine, why don't you be our last question today?
Oh God, it better be good.
Yeah, no pressure.
No, it was really an observation. I'm curious what you all think. I think one of the problems that I see is that we as human beings have a very limited life. So say we have 100 years, and that's pretty generous. In our life, we're self-centered. We want it to be good. We have the capacity to see backwards and forwards, and we want change faster than it can happen with others. And so I think we're limited that way, or we're frustrated because we do have such a small life, a short life within the big picture.
Sure. And I don't think everyone is greedy. I think or selfish. In fact, I think on a broader scale, we are much more willing to place at risk our own life for other people, even people we don't know, that we don't have a connection to.
It happens.
And I think that is more common to the human species than not. And I think those that kind of, feel I don't have to care about anybody else, I'm insulated from it. And it's their problem, not mine. I think that they are a minority, a very small minority, but they retain a lot of power and influence.
So I'm a retired therapist. I have a few patients left, and my patient this morning, who is 30, very bright, who always says, well, Maxine, you were born after 9/11. You were born after the digital age. You get information very differently. Basically, she was in total despair about the way the world is. And if we look at all of these people in this group now, she's living a different life from us. And she wants me. She doesn't say it, but she comes to me to say, give her hope. So she stays in it. So she can use her life energy to stay in it. And this is what's happening.
Well, sure. Look, hey, Maxine, if you can, please give me some hope.
Why do you think I'm taking the course?
No. But honestly, we have the capacity, because we're a species that was given this gift of intelligence. We have the capacity to actually discern right from wrong.
Tell that to the 30-year-old who just saw Roe versus Wade, separation of church and state, gun control. She said, there's nothing we can do.
Well, but I
don't believe that, but she does.
No, and I would want that person to know that what's happened today didn't just happen today.
Mm-hmm.
This is the product of 75 years of a campaign to get us to here.
Yeah.
And mind you, when we do the class on the landscape of Trump, it is really about what happened with the American Manufacturers Association during World War II. It's about what happened when there were people who saw an opportunity to take religion and to advocate for greed. But they could take scripture and have Jesus is advocating for profit. What? How did you do that? Well, but this is not something that just happened. It has been an orchestrated, and the people, and they were a small minority. By the way, they knew that if people knew what they were saying, they would never get their support. So they did it all underground. It was subterranean, because if people knew what they wanted to accomplish, they would be against it. And so they persisted. This small minority continued persisting, came up with strategies. Some worked, some didn't, and they continued on with those that worked until today. You have the kind of insanity that we have. All I'm saying is that if that person starts thinking not about, I have something I want to say, so I tweet it so everybody hears me. Immediate. If they stop thinking immediate and start thinking strategic, then they can do something. And they can reshape it. They can reshape the world. Again, I look at Europe post World War II, very different place than it is today. A lot transpired there, and it didn't happen overnight. It happened over a long period of time.
No, I try, but it's very hard to tell somebody 30 who hasn't seen changes, only negative.
Right, but
That's not true. Mostly negative.
if you take those negative events were a product of 75 years of work, then the question is, are you willing to do the 75 years of work to change
We
it
do
another
talk
way?
about passivity and activity. Okay.
You know, look, one of the reasons that I really invest a lot of time in studying what happened to Black people in America is one of the things that draws me to it is the enormous resiliency. I mean, they never to not just give up and say, look, I think the Native Americans just gave up after a certain point. The African American community, no matter how much it was beaten down, stuck at it. I mean, it's just remarkable. I think it's a testament to the human spirit that that's inspirational. And I think, you know, when we examine those things, we really look at the tortures and the, you know, horrible stuff that was perpetrated and all of that. And it can be, I don't think we spend enough time talking about how, no matter how many times you kicked them down, they kept saying, we'll create the, you know, you can burn down Tulsa and kill the Wall Street there. There was another one going to happen in Atlanta and you can kill them there. We're not giving up. We're going to keep fighting. And I think that's amazing.
Margita, we have one last quick comment.
Yeah,
and
we're
then we're
way
going to
over
let Sal tell us about next
real
week.
quick. Okay, Maxine, what I would say to that 30-year-old is to show her or have her read or look at human history.
I do.
And show her that patriarchy and hatred and injustice towards women, and of course other groups, is thousands and thousands of years old, as old as human sapiens, so-called sapiens, have been crawling around this planet, right? And where are we today? Things have changed for the better. Although we didn't get the vote until 1920 in this country, show her that we need to fight. This is not the best of all possible worlds where somebody has a purpose for us and create us for a purpose. We need to create the purpose. We need to fight, and we need to do what we can in that short span of life we have as women too, to make it a better place and to show her that it has been possible. There is a progression of more fairness and goodness, although not to all groups on this planet yet, but it can be done again.
Okay. Right.
I do.
And one more thing is Panatoia was it's a Greek word which means south, all southern land, because Gondwana became a mass of earth above water that was to the south of the planet. So they all kind of have the meanings where the other one, Rodinia, was a Russian word for mother. So, okay, well, next week we're going to look at Pangaea, which again, the continent, all that land above water, all congregates together, becomes one thing, and then it will start to break apart. But while it is like that, the Earth has become much more conducive to life, and we'll see things like the dinosaurs start to emerge and that kind of thing. So that'll be next week. With that,
okay.
Thanks everybody.
If everyone wants to unmute and give Sal a
Thank
hand,
you,
this has been
Sal.
really interesting discussion.
Thanks everyone.
And we'll see you next week.